relocated to Tokyo and made Tokyo his home. We're happy he's here. He's joined the Tokyo iOS Meetup for several meetups now and offered to give a presentation. As a reminder, all of our presenters are volunteer-based, and we always appreciate when people volunteer to present here at the meetup, and love to encourage more folks to do so. Ahmed is an accomplished author and has a lot of experience with Swift and iOS, and we're all really happy to have him here today. Thanks for coming today, Ahmed, and he's going to talk to us about building internet things. Let's give him a big welcome.
Thank you. Good to be here. Okay. Cool. Can everyone hear me? Yeah. Okay, good. What's everyone's accomplishment for the day? Today, I used my backwards GPS, and we got an adapter to work with the new MacBook. Those are my two accomplishments. In the US, I don't know what it is, but when I came to Japan with my international phone, every time I reach Shibuya, the GPS sends me in the opposite direction. So I have to actually walk to see which direction the arrow should be pointing. So I beat it today, and I made it on time. That's my accomplishment. And today we're going to talk about something related. We're going to talk about internet things, electronics, which are supposed to be smart, and then kind of an internet thing I built as a hobby. When your hobby starts as apps, then apps become your work, and then your hobby becomes writing, and then writing becomes your work. You start running out of things to do for fun, so you find new fun things, and this 3D camera was my fun thing I worked on last year, and I continue to work on it this year. So my agenda, introduction, my goal, what I wanted to build. I'll teach you guys how I did it. I'll describe some of the challenges I faced and my future plans. So introduction. 5 things about me. I've been developing apps since 2009. I started my own business. I've been working 8 years as a consultant. Other companies hire me to make apps for them. I published 2 books on iOS, one on multimedia APIs in Objective-C, one on the Internet of Things in Swift, and it's kind of the starting point for this project that planted the seed in my head. Then I did it for fun. I taught iOS at UCSD Extension. I still record online material for them. And I just moved from San Diego. So I traded endless summer for winter, and what I hear is going to be a really humid summer. But I've regained time, kind of. When you're in San Diego, it's always summer. You lose track of time. So I don't remember what winter is. I don't remember the difference between 2014, 2016. Now I'm going to be reminded of that. But I'm going to be incredibly busy, so maybe I'll have time. Other introduction. What is the Internet of Things? So we all hear this term. I wrote a chapter on this term, but it's good to describe what I think the Internet of Things is. The Internet of Things really refers to the software and hardware we're building today, whether it's websites, mobile apps, industrial hardware. And the goal is we want to enrich our lives. So by using the things better, or by making better things. So you have a smart TV, a TV that has the app you use most, Netflix, built in. You have a medical sense. You might have a running sensor that tells you how much you've walked, how fast you're running to optimize your life, or a medical sensor, a heart rate monitor, something that sends stuff to your doctor. Before we made a lot of electronics, we were getting a lot of data. We weren't doing any, people were doing some things with it, but we weren't really using the full power of logging all the sensors, running algorithms we've done before, analyzing exercise patterns, diet patterns. Today, with the Internet of Things, that's what we're working towards. We're working towards putting data into those things, getting data from those things, and then making those things smart. So that's the Internet of Things. So what did I want to make? I wanted to make a thing that would let me take 3D pictures, which is a kind of a weird idea, but it seemed fun at the time, and I was like, hey, if I can do it, why not? So the basis for it was the Ricoh Theta camera. So I don't know if you guys have played with this. The idea is it's one camera, it has 2 lenses, both are super wide, 180. You take one picture, it snaps it together, and it makes a sphere. Then you can upload it online, and see everything around you. It's really good for when you're on vacation, when you go to an event, you're look at how crowded Comic-Con is, look at how pretty Kyoto is. So 360 is cool, but the first rev, you could just take a picture and view it on a website. Second rev, they added an app. Then I thought, after using their app, I thought, wouldn't it be cool if we could do VR? Well, Rico built a VR plugin for their app, but it just shows you the circular image in 1D, in basically 2D. Like you can see it, but it's flat. I thought, wouldn't it be cool to build 3D? Like if you're doing VR, one of the things that immerses you is the depth. It's kind of that, what's it called, uncanny valley thing. When you're looking at a picture all around you and it's kind of still, you don't get immersed in it. But when you look at it and it has depth, you're like, you're in another world. And I thought, what if I could do that? So that was my project. What was another goal? Another goal was to make it a kit. So I started my own business. I'm an entrepreneur. You always think about ways you can make money off things. So I thought I'm going to make this thing, and I think a way I could probably make it a product or make it useful to other people is if I did something that you could just buy something or plug something into the camera and then use my 3D hardware to make it a 3D app. The other part of that was make it remote controlled. So does anyone do like VR or AR stuff with their work? It's really fun. If you play around with Google Cardboard or even like if you use Google Earth, you never see the photographer because basically you capture everything in that moment. So either the photographer, like Google Earth, you know, they have that big ball of cameras on top of a car and they kind of blur out the car so you can't see it. Oh, and then my screen blurs out to save power. Yeah, so like, you never have, we can make a computer that has like a touch bar, but we can't make a computer that like always stays on when you're giving a presentation. Or we don't really configure it that way. It's an internet thing that needs to be smarter. But when you do VR, like, or rather when you do 3D pictures, you see everything. So like when I was doing it like this, like you can see everything around you, but you also see my hand. And then when it does the stitching to take the two 180 images and put them together, you kind of get, your hand is really distorted. So remote control makes it so that if I just put it on a table and like go to other room and then have like a live view or something, I can just snap my picture from there. So I said I want to make it remote controlled. I can control it without touching the thing. And then the last one, I want to make it VR because that's one of the easiest ways now to like really experience 360 pictures. That was the goal. And then this is what I built. I don't have it with me because something like this is hard to take through airport security because it's a box of wires. But basically, I built a case with an on-screen display and then two camera mounts so I can mount two of these cameras. One of the things I faced when I was thinking how would I do a 3D camera is when you think about how a 3D movie is shot or is supposed to be shot, they use a lens that kind of, well, they either use two cameras set offset or they use a lens that has like two lenses inside of it, and then you get two offset images. So what I had to do was I had to build a box that held some computer guts. In my case, the guts are a Raspberry Pi, a screen so you could display it, and then the camera mounts. So all the software, all the control software runs on the Pi. This is the guts, and I can trigger it through USB. So great thing about Raspberry Pi, which I'll describe later, is that it has USB, Bluetooth, Wi-Fi built in, and it's only 30 bucks, 3,000 yen, so it's great. So yeah, I created that hardware device. You can control it through an app, and it generates cardboard compatible images. If I have time at the end, I'll show you the demo video I made on YouTube, minus the audio, because I don't like the audio, as a perfectionist. So yeah, that's what I built. And I think it accomplished my goals because I don't have to be there. I put a tripod mount on it, so it can really be remote controlled. I got the Bluetooth working, and I got it transferring images between the hardware and the app. And the hardware does all the magic stitching to make a 3D image. Cool. So the hardware, data camera, about $300, Sanmanen. It takes still images and videos just with one shot. It's not magic. You don't have to do like any weird physical things to get a 360 images. And the best part of it is it has APIs for open capture. So without those open APIs, I wouldn't have been able to do this project, or it would have taken me a lot longer. So when they built this, I think it was, what they say on their website is that it started as kind of a hobby. They had a contest to say, oh, let's do something with the camera. Someone said, let's make a 360 camera. I don't know what their thinking was, but maybe because it was a hobby, they decided to open it up. So you can control it like you would control other cameras that have USB triggers, just through the USB port. And there's also a web API, an HTTP API, where if you're on the same network as a device, you can trigger it by hitting HTTP commands to it. So that's the camera. Their use case is you use it through a phone. And that's what I wanted my 3D camera to do, also be controlled by a phone through an app. And then the images look like that. It's a distorted image, and then you run it through like a viewer, for instance, the Theta viewer or Google Cardboard, and then it unwraps the image, so it looks like a real image. Other hardware, Raspberry Pi, like sans end, $30, has ARM Linux, Bluetooth, Wi-Fi built in, and most importantly, you can buy a lot of cheap hardware to use with it. So this case and this LCD touchscreen together were also sans end, and it was $30. So for $60, I have basically a standalone computer. Awesome. Okay. So that's what I wanted to build. That's the hardware I used to build it. We're all software developers, or a lot of us are in that field. So let's talk about the software. I'm going to tell you what pieces I used to put it together. So the OS, old embedded systems, which is where I started before I did iOS, you would buy a custom operating system from like a chip manufacturer, or you'd build your own. It took a really long time, and you ended up becoming an OS specialist, not an application specialist. The great thing about the Raspberry Pi is it's kind of like the Apple II, where you don't have to know hardware to write software for it. So you can download standard Linux, and then if you've played with Linux before, you can download a lot of Linux packages to do all the hardware magic you need. So it's based off Debian, so apt-get Bluetooth will get your Bluetooth drivers for you. You can do apt-get Node, apt-get Python, apt-get Ruby, and that's your software stack. You can buy HDMI LCDs or configure Linux to use a non-HDMI display. There's an HDMI port on the Raspberry Pi, so you just plug it in and it's a monitor. This thing was built originally as a computer that kids could use to program. And to do that, they said, let's get a minimal desktop Linux running. So that gives hobbyists a lot of power. So all you're really doing with the Raspberry Pi is you're configuring Linux, you're writing your software on there. So I'll show you some code. This is the configuration code. It's just a config file that gets run by the bootloader. So that's most of the work I did on Raspberry Pi, was I was configuring the hardware, which the custom hardware I used was this LCD. Other than that, I had to configure software packages, like the Bluetooth package, and then I had to configure my server, which is Node.js. I'll talk about that in a bit. And I had to configure the utility which talked to the cameras. But I basically aggregated everything. So that's the OS. Okay, let's talk about the API. So most Internet of things work by exposing an API. They run like Apache or some other little web server, and then you can hit them with HTTP requests. That's why it's really easy to deploy like an app that talks to an Internet of Things device. If you expose an HTTP API, it's easy. The great thing about HTTP is the limitations you're running with are known givens, like having enough memory to run the server, blah, blah, blah. And you can optimize it just like you'd optimize any other HTTP server. So my API, the thing that controlled the camera, was a Node.js server running on the Raspberry Pi. To expose the API, I used Express.js. Does anyone use Node or played with it? It's cool, right? It's pretty easy to make really fast things. So Express.js, you write JavaScript, and then it'll, when you configure your web server to run with it, it'll expose endpoints for you. And then you point those endpoints to routes, which is basically what receives the code. So Express.js was how I was doing the endpoints, how I control this device. Okay, why else did I use Node? I could have used Python, I could have used something cooler, but I had already written Node code for a client, so I got really good at writing Node really quickly. And one of the things I needed to do was since it's a hardware device, I needed to take advantage of Linux. And so I wanted to run Linux command line utilities, and I did that through the exec command. So that was reason 2 for Node. Reason 3 for Node. So Linux has a Bluetooth driver. Node has a Bluetooth module that talks to the Linux Bluetooth driver. So with Blueno, I was able to set up this Raspberry Pi as a Bluetooth peripheral. So I could advertise that I'm running Bluetooth, the kind of device I was, and then I could do little commands. One of the problems with Bluetooth is you'll mostly use it for status, because Bluetooth is really slow. Bluetooth is about 22 bytes, I think, per second. So when you have Bluetooth headphones or something else, sometimes if you notice they're slow or they break up, they have to build up a buffer for it to work. So Bluetooth was what I used to advertise the device, to find it on the app, and to get status from it. But to transfer the images, I had to use regular HTTPS over Wi-Fi. But Bluetooth was really good because it started making the remote control. Then the last reason was async. So I'm using Node to take pictures on a camera, and then I have to wait for the cameras to finish. That could be really bad, especially for a user. They can wait 5 minutes. They don't like to wait 5 seconds. So Node has an async module, and that's kind of how you get threading going. You can make asynchronous methods and tasks and have completion blocks. So basically what I did was you take the picture, I immediately send back a status message saying the camera's taking a picture. Then I have the async tasks running. I update the status, and when it's done, I send another message saying, the image is ready, you can download it now. But without async, you take a picture, everything locks up for 5 minutes, the user throws it on the floor, and then you have a bad experience. So if you haven't seen Node code before, Node is just JavaScript. It's really easy. This is the Bluetooth advertising code. This is actually how you make an iBeacon. iBeacon is basically a Bluetooth device that just advertises a special UUID. The UUID, I think, is everything except the last 4 bytes. That's how you identify what your device is. But what you're doing is, when Node starts running, when your application is up, you tell it on Bluetooth, advertise this signal, saying, I'm a iBeacon compatible device. And then there's also similar callbacks you have to say, handle this incoming message. Handle this message from whoever's talking to me. So that's Node. It's pretty easy. It's easy to learn, but like all JavaScript, it's a pain in the butt to debug. And I still don't like the debugging tools. But hey, I dealt with that on other projects. That pain. Cool. So that's the API. Now how do I control the device? So the OSD is on screen display. That's the little software that runs here. My idea was I'm building this internet thing, and if I can't talk to it through the app, I should see warning messages or have a test button on here. Old school embedded systems, you would write it yourself. You'd go in there and say, force this to run and do this and that. Luckily, because I'm running on Linux, I could run a shell script that runs an application when I boot. And luckily, because I'm on Linux, and a lot of people use web apps now, Chrome has a headless mode. So when this device boots, it loads Chrome in headless mode, which is basically it loads a website, a browser with no controls. And so as far as the user is concerned, he sees an application. And that application is an Angular user interface, which just has the buttons. And those buttons talk to the API endpoints. So the buttons use the same endpoints as the hardware, and they're just show the status and let you take pictures from the camera directly. Another cool thing, reason why I used Angular was kind of going horizontally. When you learn iOS, you get very good at MVC, and Angular 1X is MVC based. So if you've spent a lot of time doing learning Angular's design pattern and separating your code that way, it's pretty easy to get started on Angular and put something out there. It also helps you preserve your sanity. Angular 2, I think, is closer to React, where it does its own event system, which might be better for Android guys. Oh, this is an iOS group. So I can talk about iOS all day. Cool. And so let me show you some Angular code. So if you haven't done Angular, this is just an example of, I guess, more of the MVC part of it. Basically, what you're doing with Angular is all like the MVC layer, all that stuff is done in JavaScript, and the V, what you output is basically like template code. This is the HTML file. You'll set like these identifiers inside your JavaScript, and then in your HTML you tie it back together, and then it'll find it and replace it. So here I have a driver object, and these are the properties. And if I'm building, like in here, I'm building a table, and I just want to read the values out of the table, I use standard like template language, and then I just use the identifier for the object. And then if you'll see down here, and that's basically how you output stuff, how you build a view in Angular. And if you'll see down here, MVC, it's split up. Like you kind of split up your JavaScript like you would on an iOS MVC app. So that was Angular. It was cool. Now let's talk about the stuff you guys want to hear. iOS. So how do I network with the hardware device? And this is something you'll face a lot. Before I worked on this for fun, I worked on a medical device for a client, and it was basically like, kind of like a breathalyzer, but it was powered with Bluetooth. And the way you use it is by using core Bluetooth. You can read more about it in the book, but Bluetooth has two roles. It has a peripheral and a central manager. So like the peripheral is something that advertises data or like sends commands. And the central manager is the thing that's sending commands to them. So in most apps where you're talking to a Bluetooth device, your hardware is the peripheral, and then your app, whatever your phone, is the, one of my phones. Your phone is the central manager. So what you're doing in core Bluetooth is a lot of delegates, like you're implementing the core Bluetooth protocol, and the one you're concerned with is central manager. And like I said before, Bluetooth is really slow. So what you want to use Bluetooth for is use Bluetooth to find this device, and then to like send requests for status, and then get status back from the device. You can't use Bluetooth, or you shouldn't use Bluetooth to send back images, because in this case, my images are 5 megabytes, and 5 megabytes times 22 bytes per second is going to take a very long time. So use Bluetooth to find the device, send back any information you need, and then over Wi-Fi, download the images. So for Wi-Fi, use your favorite networking stack, URL session, Alamo Fire, AF networking. It's up to you. Just make an HTTP call to the hardware. Okay. And it's a lot of content, but I hope I have time for questions. So networking, like I said, you're going to focus on CB Central Manager Delegate, and then the good thing for you is the code you're writing is basically you call a couple of singletons, a couple of methods on singletons to say, I want to use Bluetooth, I want to do this, and then you say, you set a delegate. This is Objective-C. But the idea is you're implementing the protocol methods. And the ones you're most concerned with are did connect, did discover, and did update state. So what happens is you'll turn your app on, you'll say to the manager, start scanning. Then when it scans and it finds something, it calls did discover. That's when you say, start setting stuff up. Say, I found something. Step 2 is you try to connect. That's where you use did connect. When you've connected successfully, the callback ties to did connect, and that's when you start setting up your code. And then 3, did update state. Most Bluetooth devices work as a state machine. So one of the messages you're going to get back is like a status update. That's kind of what you're going to be sending from the device and then did update status, once you've connected, it's always going to be like listening for those messages. And when it gets it, it's going to do something. It's up to you. So that's Bluetooth. And there's a lot more in my book about it, at least 2 chapters. It was fun to build. And then I don't need to talk about AF networking. Most people know that. But I will talk about the last software component, which is Google Cardboard. One of the reasons I wanted to use Google Cardboard is Google, you remember when they announced Google Cardboard, they gave everyone a piece of cardboard with some lenses. Since then, a lot of companies build their own viewers. Like this is my favorite one. It was $10. It folds up in a nice little case. But it's a standard. So as a standard, the idea is everyone tries to build something that matches Google's spec, and then you give your identifier through a QR code. Every Google Cardboard device has a QR code, and then the rest is up to Google. So Google has an SDK for iOS native, Android native, Unity, and the web, which is a Google Cardboard viewer. And you just give it stuff, and as long as it's compatible, like if it's a 3D world you built in like modeling software or Unity or an image, if it's compatible with what they support for viewing like 3D images, you can use it in there. And the interface to that is GVR Cardboard View, which is a subview of UI view. And as you'll see in the next slide, it's really easy to set that up. So once I got the image back from the camera, and once I did some magic on the hardware to make it a Google Cardboard compatible image, I plugged it in the Cardboard viewer. And that's really all you do. You initialize whatever your object is. This is from Google's tutorial. They have like a test app called Treasure Hunt, where you're basically, it's a 3D world and you're trying to find something on there. And so that's what you want to display, and then you just display it in your Cardboard view. And that's Google Cardboard. So that's how I made a 3D camera. And I think I'm out of time, right? But a couple of things I wanted to say is, next thing I want to do is make a case so I can take it through airport security. Maybe add like 3D video or audio. And one of the worst and most annoying challenges I had was USB cable quality, because you would think all micro USB cables are the same, but they're not. And I spent a week trying to figure out why my USB wasn't working anymore, and the cable was bad. So yeah, cool. And that's it. Hope you enjoyed
You
it.
got some time.
Oh, okay.
Yeah, you got a little bit of time.
Okay, good.
Yeah.
Well, let me show you the video just to fit in action, and then ask me any questions. It's a lot of content. So let me do that. So I don't like the audio, I'll just narrate. I recorded this at 5 a.m. So the idea is you have your controller, and then it has a tripod mount, and it has a USB sticking out. So you mount 2 cameras on there. Oh, cool finger. You mount the 2 cameras on there, and then you just turn them on. Once it's powered, the utility I use to scan for cameras will detect it. And the on-screen display shows you if camera 1 or 2 is on. Then you open up the app, and it's a UI I made in an hour to get the job done. And it basically shows you the status. It reads those statuses from Bluetooth. If it can't find the Bluetooth at all, it's red, nothing shows up. Once it shows Bluetooth, it does red or green, depending on whether or not the hardware is connected and working. And then, yeah, everything's working. You hit the take picture button. Then, yeah, the cameras start flashing because it's triggering images on the it's triggering capture on both the cameras. And then, once it gets back the image, or rather the status that the image is done. Yeah, that's me when I recorded the video. It creates a sphere, and then if you put it in Google Cardboard, yeah, hey, then it's a 3D image. And because of the Google Cardboard SDK, it changes the borders depending on the viewer. So some viewers are really big, some are small. And that's Theta 3D. Okay, that's my internet thing. Thank you for your time.
Questions for Ahmed?
Ask me anything. Yes.
So like when you initially started doing this, did you approach it, you know, in sort of the hobbyist mentality of kind of just tackling problems as you went, or did you actually, your sort of, you know, professional experience have you like actually organize this project in a sort of structured way? Just curious.
This was for me, and I think the way I organized it, well, I set up a Jira and everything else and made tasks and assigned them to myself. But other than that, it was kind of like I used my experience. I basically did it, I guess you could say it was very agile without me thinking about it. I did it in steps. I said, could I trigger a camera? And I was like, yeah, I could trigger a camera. So that was step one. Step two was like, okay, can I get Google Cardboard to work? Oh yeah, I got Google Cardboard to work. Then step three was like, can I make an image and then send it? So it was just like putting pieces together. I had this idea, then I tried all the little pieces, and then when the pieces were done, throwing it all together.
Okay, cool.
Yeah, that's how I did it. But one of the things I want to do is I want to make it more real. One of the implementation challenges is since it's all JavaScript, it's all out in the open. So I can't really I could open source the device or I could make it closed source. But right now it's kind of like hobbyist code that needs to be tuned faster and made more secure. So, yeah. Cool. More questions? Yes.
Relating to, this is, I guess this project, you just mentioned it at the end in your last sentence, but with IoT, I think one of the big concerns is security. Like we're putting more and more internet-connected devices in people's homes, and you know, there's like security cameras that apparently can now run like virus botnets and things like that because they're not properly secured. What are some of the steps that someone should take in order to see that their IoT application is secure?
Well, so the good thing about IoT for a hobbyist or for a startup is you can start to build something really quickly. The other good thing is it uses open standards like HTTP, Apache. What you need to do is I recommend you do best practices. So if you kind of like any software business, you get your Linux kernel under control. You monitor the security problems for your Linux kernel. You monitor the security problems for your Apache, and then you just do all the stuff to avoid intrusion you do on a web server. That's the best way. And then what's really important is you don't advertise what hardware you have. But there was a botnet which did some damage recently running off IoT devices. And one of the problems was a lot of the big companies were using a vendor for their IoT stack, and they were all basically using the same faulty web server, faulty Linux distro, and they wrote this botnet which basically sniffed for that. Then once it found it, it ran that software on there. So you kind of want to cover up what you're doing and make a really good, really solid web server.
Hi.
Yes.
The production, how long it time?
So, what did I do? I'll tell you how long I wanted to work on it. I think I worked on it I started working on it last January, and I didn't do it until July. I did it in about a month. I put this together in a month. Yeah, it took me, I think, a month, half time, maybe 20 hours a week. But my idea was to build a prototype, right? And I built the prototype. It was good. Yeah, that's why a lot of things are still rough. That's also why I use Node, because I wanted to write something really fast. So it's cool. Good. And then one of my biggest regrets, like I said, is the case, because I think it. This one, I don't know laser cutters or 3D printing yet, so I just did what I could, which is I went to Radio Shack, Fry's in California. I bought a case and a Dremel and I cut the holes out myself. But to make it a real product, you need to have something that looks really good and is really appealing to consumers. And yeah, it's cool.
I have a question.
Yes.
I have Raspberry Pi 2,
Okay.
in my storage.
Yeah.
And you use the Raspberry Pi 3.
Mhm.
How do you think it's like much better than Raspberry Pi 2, or how do you feel like?
Yeah. So the biggest difference is 3 has the Bluetooth built in, so you don't have to buy your own Bluetooth dongle. For the price, like today, you should buy the 3 because it's the same price as the 2. The biggest strength, well, one of the potential biggest strengths of the 3, right now the biggest strength is it's the same CPU architecture as the 2. So all your software will run the same, all the drivers work the same. The biggest weakness is that they didn't unlock the processor. Like I think it's a 4-core processor, but they're still using like the dual core stuff that the 2-core was using. So for the money, I'd get the 3, but if you have a 2, you can do all the same projects. You just buy your own Bluetooth for like $10, that's it. Yeah. It took me 2 years to set up my Raspberry Pi, too. I bought it, and it sat on my desk for 2 years. Then I opened it up, and in an hour it worked. It was great. So, cool. All right. Awesome.
This screen you bought for Raspberry Pi,
Yeah.
did you buy it here in Japan or in the US?
I bought it in the U.S. on the most accredited source for electronics, Amazon.com.
Okay.
Searching for Raspberry Pi LCD.
Actually, I was
Yeah.
looking to buy a screen here, but I didn't find any.
It's
location
hard.
Here and, yeah.
I spent maybe the last 3 weeks like going around to try to find stores. No, Amazon's probably the best source, or Alibaba. But something I would advise is there's a part number, and look up that part number, because there are some parts which, like the chipset they use, works with Raspberry Pi, and there are some that don't. So when you look up Raspberry Pi LCD, look up like Raspberry Pi LCD 2016 working.
Actually,
Yeah.
the biggest thing is the portability. I want to maintain the portability. So
Oh.
Raspberry Pi itself is so small, so I want a screen which actually perfectly fits, like
Yeah.
you're carrying. So
Yeah.
something of that sort. But I just didn't find any.
Yeah, just I think I can send you an email.
Yeah, I did.
Yeah. It's fun. Good. Yes.
Awesome project.
Oh, thank you.
And I'm curious about the speckles. It's the first time I see
Oh, okay.
this kind of thing.
Yeah, so it's just
How do you use them? Like I know the cardboard. You use it like this.
same one. Yeah, so this one is just a plastic. 1 second. This one is basically the cardboard is a cardboard box with these 2 lenses that kind of make you cross-eyed, and then there's a slot where you put your phone. And this is just a plastic version of the same
You
thing.
still hold them.
Yeah.
Ah, I see.
But you hold it like this.
Ah, I see.
And the cool thing about this is if you have glasses,
Ah,
you can use it.
The outside light doesn't interfere at all. I thought it needed to be closed. I
If you want the best experience,
see.
it's like home theater. If you want the best experience, but when you're looking at an image, and I can pass this around, or people can ask me if you want to play with it later. If you want the best image, you need to make sure the image is good. Just like a movie. If you're watching a movie that's shot poorly, it doesn't matter how you're watching it. So yeah, when you're doing VR, you're focused on this most of the time.
Yeah, you got this here, the speckles here.
Amazon.com. I bought it in the US, but it's all made in China. So you can find it on, I haven't had trouble finding stuff on amazon.co.jp. And then since we're in Asia, Alibaba is pretty easy to use too. And I'm sure Yahoo Japan and Rakuten can find it there too. So,
All right, maybe one more question.
okay. One more question. My favorite coffee is Guatemala, if you want something to talk about later. You could ask me coffee, you could ask me cherry. You could ask me about the weird looks you get when you use VR. Okay. I guess last comment is when you testing this is the first time I ever become seasick. Because basically it's cool to look at VR for 10 minutes, but after about 4 hours, it's disorienting. And the one of the problems with VR2 is, you know, photography is all like where you shoot it. With this one, like if you do VR for Google Earth, you'll seem like a ghost because it's shot about 10 feet off the ground. With this, it's kind of like if you shoot at eye level, it feels like you're eye level. Stuff like that comes out a bit more. And another big problem I had was separation of the cameras. When it's too far apart, you're like, oh. You feel really sick when it's too close, you're cross-eyed. So like this picture actually is me with the two cameras on balsa wood, because I kept drilling holes like a couple of centimeters apart each time to see what would make me the least seasick. Yeah, it's fun. Good. Well, thank you guys. I had fun.